there is a question nobody is asking loudly enough. Not the question about whether AI will take your job. That conversation is already happening. In boardrooms, in policy papers, in headlines. Not the question about whether AI will become more intelligent than humans. That debate fills entire academic journals. The question nobody is asking loudly enough is quieter, more personal, more unsettling. What happens to you? Not to the economy, not to society in the abstract, but to you, specifically, as a thinking, reasoning, deciding human being. When the act of thinking itself is increasingly outsourced to a machine, what happens to a muscle that is never used? It atrophies. What happens to a skill that is never practiced? It fades. What happens to a capacity for judgment, for reasoning, for tolerating uncertainty that is systematically replaced, one small convenience at a time, by something faster, more efficient, and always available? That is the question. And the answer is one of the most important things you could understand right now. To understand what is at stake, you need to understand what thinking actually is, not the pop science version, not the left brain versus right brain mythology, not the 10% of your brain nonsense. The actual cognitive science of what happens when a human being solves a problem, makes a decision, or forms a judgment. When you think, really think, you are doing several things simultaneously. You are retrieving information from memory and evaluating its reliability. You are identifying patterns and testing them against exceptions. You are tolerating the discomfort of not knowing while continuing to reason. You are making probabilistic judgments under uncertainty. And crucially, you are building, through each act of reasoning, a more refined, more calibrated mental model of how the world works. This last part is the one that matters most. Every time you work through a problem yourself, you are not just solving the problem. You are upgrading your capacity to solve the next one. The thinking is the training. The struggle is the development. Cognitive scientist Stellan Ohlsson at the University of Illinois has spent decades studying what he calls deep learning. Not the artificial intelligence version, but the human version. The process by which genuine understanding is built through productive failure, through encountering the limits of your current mental model and being forced to revise it. In plain English, you do not learn to think by being given answers. You learn to think by being wrong, noticing you are wrong and figuring out why. Now imagine a system that eliminates that process entirely. Not dramatically, not all at once. Gradually, gently, one small convenience at a time. A system that answers your questions before you have finished forming them. That summarizes the document you are about to read. That makes the recommendation you are about to deliberate over. That drafts the email you are about to compose. That navigates the route you are about to figure out. That schedules the meeting you are about to coordinate. Each individual instance seems trivial, harmless, efficient. Why spend 20 minutes reading a report when an AI can give you the key points in 30 seconds? Why deliberate for an hour when an AI can model the decision for you in moments? But here is what is actually happening beneath each of those conveniences. Each time the AI thinks for you, the neural pathway that would have been activated, the one that retrieves the information, evaluates it, connects it to prior knowledge, builds the mental model, is not activated. The cognitive work is not done. The capacity is not exercised. And over thousands of such instances, accumulated across months and years, the architecture of your thinking begins to change, not in a way you can feel, not in a dramatic, detectable moment of decline, in the same quiet, incremental way that any capacity degrades when it goes unused. This is not a theoretical concern. There is already evidence that this process has been underway for longer than most people realize. In 2000, before smartphones were widespread, cognitive scientist Betsy Sparrow at Columbia University began a series of experiments that would later be published in Science magazine. She wanted to understand how human memory was changing in response to the availability of internet search. What she found became known as the Google effect. When people know that information is externally available, that they can simply look it up whenever they need it, they are significantly less likely to store it in their own memory. The brain, operating with characteristic efficiency, offloads information to external sources rather than encoding it internally. Why remember something you can always retrieve? The answer? the one the brain does not compute, is that memory is not just storage. Memory is the raw material of thought. The connections between memories, the associations between stored ideas, the ability to draw on a rich internal model of the world. These are the mechanisms of insight, creativity, and judgment. When the storage is offloaded, so is the substrate of deep thinking. Sparrow's research was about search engines. The phenomenon she identified is now orders of magnitude more significant in the age of large language models that do not just retrieve information, but synthesize, reason, and decide. There is a concept in aviation that captures this dynamic with startling clarity. It is called automation bias, and it has been studied extensively by human factors researcher Raja Parasuraman at George Mason University. Automation bias is the tendency of humans working alongside automated systems to over-rely on the system's outputs, to reduce their own monitoring, their own verification, their own independent judgment, because the system is usually right. And when the system is usually right, the cognitive cost of always checking it begins to feel unnecessary, inefficient, even arrogant. The problem is not the individual instances where the system is right. The problem is what happens in the rare but critical moments when it is wrong, and the human operators, having gradually reduced their independent cognitive engagement, no longer have the situational awareness to catch the error. This dynamic has been implicated in multiple aviation accidents, including the 2009 Air France Flight 447 disaster, in which a sophisticated autopilot system disengaged unexpectedly, and the pilots, having spent the preceding hours in passive monitoring mode rather than active flying, were unable to correctly diagnose and respond to the situation in time. The plane had been thinking for the pilots, and when it could not, they were not ready. Now scale that dynamic. Apply it not to pilots in a cockpit, but to knowledge workers in offices, to students in classrooms, to decision-makers in institutions. Apply it to the daily, unremarkable act of thinking that constitutes the fabric of human intellectual life. What happens when an entire generation grows up with a cognitive prosthetic that is always available, always faster, always more comprehensive than their own thinking? What happens to the development of judgment, not just the recall of facts, but the capacity to evaluate, to question, to sit with complexity and reach a reasoned conclusion? Psychologist Jean Piaget spent decades documenting the stages of cognitive development in children, the process by which abstract reasoning is built through repeated encounters with problems that require genuine mental effort. His foundational insight was that cognitive development is not passive. It requires struggle. It requires the experience of being wrong. It requires the productive discomfort of not knowing. If that discomfort is systematically eliminated, if every moment of not knowing is immediately resolved by an AI, if every question is answered before the effort of reasoning can begin, what is built in its place? Here is the counterintuitive part. The answer is not to reject AI. That is not only impractical, it misses the point entirely. The most sophisticated chess players in the world now train with AI. The most productive researchers use AI to accelerate literature review. The most effective communicators use AI to sharpen their drafts. The difference, and it is everything, is the relationship between the human and the tool. When you use AI as a first draft, a starting point, a thing to argue with and push back against, when you bring your own judgment to bear on its output, when you use it to extend your thinking rather than replace it, the tool amplifies intelligence. Your intelligence, your capacity grows. When you use AI as a final answer, when you accept its output without evaluation, when you outsource not just the labor of thinking but the responsibility for it, the tool substitutes for intelligence. And over time, your capacity quietly, incrementally diminishes. Researcher Lev Vygotsky described the concept of the zone of proximal development, the productive space just beyond your current ability, where challenge and support are optimally balanced. Learning happens in that zone. Growth happens in that zone. The best use of AI is to expand that zone, to make problems that were previously inaccessible now within reach, not to eliminate the zone entirely by doing everything for you. The divide forming in the world right now is not between people who use AI and people who do not. Everyone will use it. The divide is between people who use it with cognitive intentionality, who remain the active thinker, the critical evaluator, the final judge, and people who gradually, imperceptibly, cede that role to the machine. The first group will find their intelligence amplified, their judgment sharpened by the contrast with AI output, their creativity extended by tools that handle the mechanical while they manage the meaningful. The second group will find something harder to name and harder to recover. Not a loss they can point to, not a skill they can identify as gone. A general softening of the cognitive edge, a growing dependence on external answers, a quiet incremental erosion of the confidence, earned through practice, built through struggle, that comes from knowing you can think your way through hard things. This is why organizations like Pinnacle AI Solutions focus not just on AI adoption, but on AI integration that preserves and develops human cognitive capacity. Because the future does not belong to people who can use AI. It belongs to people who can use AI while remaining the most important intelligence in the room. There is a question nobody is asking loudly enough. What happens to humans when AI does all the thinking? The honest answer is, it depends entirely on you, on whether you treat AI as a tool that serves your mind or as a replacement for it, on whether you remain the thinker, the judge, the one who holds the final question, or whether you gradually, quietly, step back from that role and let something faster, more efficient, and completely indifferent to your development take it. The machine does not care whether you grow. It does not care whether your judgment sharpens, whether your reasoning deepens, whether you emerge from each interaction more capable than when you entered it. You are the only one in this relationship who cares about that, which means you are the only one who can protect it.